going to go on to what I absolutely love. This is an air turbine tool on a torn-off Swiss lathe. Now, these Swiss lathes are absolutely dear to my heart. They're lovely machines, but the driven tooling can't quite get up to super high RPMs. So first of all, could you just show us where the actual air turbine tool is? Because it's absolutely tiny. It fits in with the tiny tools and torn-offs really well.
New 800 series air turbine spindle. And as you can see here, it's a 25 millimeter OD, and it will fit into any standard boring holder inside of the Tornos.
So it's just it fits in a standard tool pot in a Tornos machine, and probably other sliding head lathes as well. Yep. But why does it fit so well inside this machine? I mean, if we look at the part over here, why does it make that part so well?
Well, because of the higher speeds, we're able to get better finishes, and we also have 2-micron CIR. So these machines are designed for small parts and high-speed production with small travel. But the only drawback is the live tooling. So when you're trying to do off-centered cuts, you're limited to 6,000 RPM, whereas this one is 80,000 RPM. So we can exponentially increase your feed rate, which exponentially cuts down your cycle time and increase your profit margin.
Why is it important on specifically a machine like this? I mean, how many parts a month might you look to make on this machine, and what kind of benefits would a small cycle time decrease on a single part give for you?
Well, you could make the difference between 1,000 parts a week to 100,000 parts a week.
Which is huge if you're trying to make orders and stay competitive in what is a difficult world. And investing in just a single air turbine would allow you, I mean, would that allow you to, is it the fact that you can make very different parts of medical that require those surface finishes, otherwise you'd have to take it for a secondary polishing operation. But what are the benefits to what, surely it'd be nice to not have to buy an air turbine tool and polish it otherwise. Why would you want to do that all in one machine?
Well, the problem with polishing is you're relying on somebody's hands, and they can make a mistake. They could drop the part. They can ruin your
form, the dimensional form. Of the
right.
part.
Yeah, and then scrap always costs 3 times more than a new part. So if you can do it in here and cut out all those variables and do it very quickly and make it profitable, then you've made something here.
Absolutely, cutting scrap out, and I guess a person is going to make. You might have, if you got 100,000 parts, that's a lot of people polishing, and that's a lot of variations in the size in the part. And I guess medical, they want all the parts to be the same every time.
Absolutely, yes.
Brilliant. So medical is absolutely fascinating. I love these machines; are fantastic. But what about the air turbine tool's design? I mean, what RPM can this get to? Surely at that size, it can't get to much higher RPMs.
Well, actually, these will go 60 to 80,000 RPM.
80,000 RPM.
Absolutely, and it just runs off a clean, dry air.
And what about the heat generated? Surely at 80,000 RPM, they must generate a lot of heat and reduce your thermal expansion, reduce your tolerances. Surely there's a lot of problems with 80,000 RPM.
Well, you would think so, but actually this tool is constantly air-cooled, and there's no brushes, vanes, or gears, so that means there's no thermal growth, and there's no friction. So you can run this 24 hours a day, 7 days a week.
24 hours a day, because normally there's on mostly machine spindles, there's like a duty cycle. They say you can run this RPM for this amount of time, but with these you can run them 24/7.
Yep, no duty cycle, no warm-up, no wires, no extra hoses, just one little air hose, and you're ready to go.
And that's a really simple way of doing things. You don't need any electronics, no controls. You just spin it up, easy as that. Now, that sounds really easy. There must be there must be a reason that people wouldn't want to use. I mean, 80,000 RPM, it's a very high RPM. Surely you want to achieve a certain surface speed with your tool. So, I mean, what kind of tools would you put into the 80,000 turbine tool?
They would be all for micro tooling, which is perfect for the Swiss because it's all about micro tooling. And this allows you to do it much, much faster.
Thank you, Russell. Right, that's enough about the absolutely fascinating mini motor mount.